This video is part 2 of the Inequalities Algebra unit. We had been talking about some of the terminology used with inequalities, things like at most, no more than, at least, and now we're on the wording no less than. X is no less than. We see the word less here, but we look over here at this symbol associated with it, and it's a greater than or equal to symbol. So let's look at that wording. I've put this example up using the words no less than. You need no less than 50 points to move on to the next round of the game. So what does it mean for you to need no less than? Can you have less than 50 points to move on to the next round of the game? No, you need no less than 50. That means you need 50 or more. So for this one, we would write X is greater than or equal to 50, because you need more than 50. So this wording, at most, no more than, at least, no less than, you will see this again, and you'll see when we're talking about probability, it'll say something like, what's the probability that it is no more than 5? And you'll need to know, what does it mean for something to be no more than 5? And you'll need to know that that's 5 or less. So it's really, really important for you to understand this wording so that you can set your probability questions up correctly. Okay, going back to the worksheet, let's look at number 1 and go through some of these scenarios. It says write an inequality to represent each scenario, then graph the inequality on the number line. So I've pulled it up here. It is over 100 degrees today. So you're always going to start off with an X unless they tell you otherwise. I think in the homework mostly they have us using X. So over 100 degrees, does that mean that it's less than 100 degrees? Degrees like 99, 98? No, it's over. So it's 100, over 100. So over or greater than 100. Now the question is, does it include 100? It's over 100, so 100 is not included. Okay. So now with your number line, you can number these. You can decide where the 100 is. I'm just going to put it here in the middle. So this is 100, this would be 99, 98, 97, 96, this would be 101, 102, 103, so on and so forth. But wherever you put that, now we need to decide, is this an open circle or a closed circle? There's no line here, so it's an open circle on 100. And then we need to shade our line to cover all the numbers that are greater than 100. So that's all the numbers to the right. And don't forget to shade your arrow as well. Okay. I have less than $50 in my pocket. So I have less than $50. So let's just find a place and put a 50. So if we have less than, does that equal to 50? No, it's less than 50. So we want an open circle, and then less than would be shading to the left. All right, she is between 70 and 80 years old. Okay, now this one is a little bit different. She's between 70 and 80 years old. So this one is written a little funny. So we're going to put X between 70 and 80. And then you use, always when you write it like this, you always use less than signs. And this shows that X is greater than 70, because 70 is less than X. And X is also less than 80. So she's between 70 and 80. Does that include 70 and 80? Years old? She's in between the two. It doesn't mean that it's necessarily included. So they didn't say that it was included. So if they don't say that it's included, then you can't put the equal signs. They might have said something like she's between 70 and 80 years old inclusive, and that would mean that it included 70 and 80. So if this is 70 here, and this will be 80 because I believe there's 10 tick marks across, we would do open circles on both 70 and 80, and then we would shade in between, just like that. So you wouldn't shade any arrows, it would just be between those numbers, and that's it. Okay, he has at least one brother, but no more than 5 brothers. Okay, so let's do this one at a time. At least one brother. So remember, at least is not less than 1, it's more than or equal to 1. But it says that he has no more than, so that's less than or equal to 5. So now we're going to kind of put those two things together. X is greater than or equal to 1, but it's less than 5. So that means that X is between 1 and 5. And it's greater than or equal to 1. Now, I know I've drawn a less than sign, but if you look at it backwards, well, let's look at front ways first. 1 is less than or equal to X. If we read it backwards, X is greater than or equal to 1. And then X is less than or equal to 5. So that's how we would put it together. So if we had, this is 1, 2, 3, 4, 5, we would put closed circles on the 1, a closed circle on the 5, and we would shade in between, and that would show that he has anywhere between 1 and 5 brothers. Okay, let's move on to number 2 on the sheet. We're going to start solving some inequality equations. So the rules here are just like solving regular equations. So I'm hoping you will remember some of this from a previous course. So let's look at A. A has y minus 5 is less than 10. So we're going to treat this inequality symbol, we're going to treat that like it was an equal sign. And so basically what we want to do is we want to draw a line. You don't have to do this, but I like to do this when I'm teaching people to start out with equations and inequalities, to see that there are two sides of this there's two sides of this inequality, and our goal is to figure out what y is less than. If it was an equal sign, we'd want to know what y was equal to. So what we're going to do is we're going to undo everything that is happening to the y. We're going to undo every operation. So if it's subtraction, we undo it by addition. So we're going to add 5. And the rule is what you do to one side, you do to the other. On the left-hand side, we did nothing to the y, so we leave that y. Negative 5 plus 5 cancel. We leave our less than sign, and then 10 plus 5 is 15. So y is less than 15. So we're going to say, okay, let's say this is 12, 13, 14, here's 15, here's 16, so on and so forth. So on 15, we'll do an open circle, and we will shade to the left. All right. Moving on to number 2. This one has a little bit more to it. It has a variable on each side. Still want to draw a line down the center so that I can see my left from my right. See that there's two sides here. There's two x's. There's one there and one there. So what do we do in this case? If you really what you want to do is you want to look at your left side, look at your right side, and see if you can simplify it at all. Can I add 3x plus 8? No, they're not like terms. Can't add anything together over here. So if you cannot If you can't simplify either side, then that's when you start with your undoing. Undo all the operations. Now, the problem here is I've got an x on each side, so which one do I start undoing? Which x do I want by itself? So what we're going to do is we're going to combine the x's. Now, you can't add them together like this, 3x plus 5x, because they're on separate sides. We need to get them on both sides. So you have two choices here. You can undo adding the 3x, or you can undo adding the 5x. I usually undo the smaller of the two. If we were adding, I usually subtract, get rid of the smaller number. So I'm going to subtract 3x on both sides. You could also subtract 5x on both sides. It's up to you. Okay. Now when I do that, this 3x minus 3x cancels. It leaves 8, it leaves 8 because the 3x's cancel, is less than or equal to 4 plus, oops, that is not right. It does not equal 5x. It equals 5x minus 3x is 2x. Okay? Now we still want x by itself. Now we can start undoing. So we are going to undo, we can undo the adding 4, or we can undo the dividing by 2. So I usually get rid of whatever's being added or subtracted first, because it's usually a little bit easier, less complicated that way. And we get 8 minus 4 is 4. Leave our sign the way it is. 4 minus 4 cancels, and it leaves 2x. Now we still want x by itself. So hopefully you'll remember what you do when you've got multiplication. You do the opposite, which is division. So I end up with 4 divided by 2 is 2, is less than or equal to 2 divided by 2 is 1, 1 times x is x. Now here's the thing. If this were 2 equals x, I would just leave it alone. But it is not equals. It is an inequality. So we want to write the inequalities with either the x's in the middle or the x's in front. So if we flip this around, it's not going to be x is less than or equal to 2. X is greater than or equal to 2. So see how it's open on the side that's over with the x, and it's pointing to the 2. The same thing needs to happen when you flip it around. So if we have here's 0, here's 1, here's 2, here's 3, we're going to do a closed circle on the 2. Make sure it's closed, and we're going to shade to the right. Alright, let's look at the next one. Negative 2x is greater than 4. There's nothing to do on the left or the right as far as simplification goes. But this one is special, and if you look over here, I've got a new rule that you need to know. This is really important. If you multiply or divide both sides of an inequality, not an equation, but an inequality by a negative number, reverse the inequality sign. This is really important. So you don't do this if you add or subtract a negative number. You only do it if you multiply and divide both sides by a negative number. So let's look at this one. Negative 2x is greater than negative 4, so I'm going to divide both sides by negative 2. Okay, so negative 2 divided by negative 2 is positive 1. That leaves x. 4 divided by negative 2 is negative 2. However, I need to reverse this inequality sign. It's no longer greater than, it is now less than. And let me show you like a little experiment over here on why this is the case. So let's take some numbers we know well, like 5 and 7. This would be true to say, correct? 5 is less than 7. So what if I multiplied both sides by negative 1? If I did that, I now end up with negative 5 and negative 7. Is negative 5 less than negative 7? No, it's not. Let's see, negative 7, negative 6, negative 5, negative 4. Negative 5 is definitely greater than negative 7. So we want to reverse that sign. So anytime you multiply or divide both sides by a negative number, make sure you flip the sign. And so if we have a negative 2 here, we're going to open circle and we're going to shade it to the left. Okay, looking forward to part 3.